Good afternoon. I'm Dianne Anderson. I am the director of the Energy Institute here at Case Western Reserve University. And a lot of folks get to lead panels with members that are well respected and well known, but I really do today. So in a moment I'll introduce them, but I would say that this is an excellent opportunity to take a look in alternative energy at what's going on. We have representation obviously from academia in terms of what research is happening in the area of alternative fuels. We have representation in government and in funding. We have representation in industry and those that have end users that will use it. So we're well covered. In terms of what we are looking to for alternative energy, there really are two areas that I know in the 6-7 months that I've been here, we have put our focus into. One of them is how do we drive the research of the future and the solutions of the future and drive it in a way that we know that there is an industry at the other end that's interested in it. So I ask myself, as well as all of us today, to listen for some of that inside of the presentations, because it takes everyone at this table to work together to make sure that we not only have the great ideas, but as well as the great ideas, we have the participants, the applications, the industry, the end users that are very interested in this. And the other thing that has always come to mind for me, and I know Ewan Alexander, who is our faculty advisor at Case Western Reserve University, is also in the audience today, that has been particularly important to us is, and how fast can we do it? So again, it is my own personal characteristic, but it always is one of looking at being first isn't necessary because being good is critically important. But as we move forward, being able to look at the opportunities and how quickly they can make it to a marketplace is awfully important to us. And I know we're working on that at the Great Lakes Institute, and I welcome those that are going to speak today to think in that perspective as well. So with that, if I can give an introduction, and they also can provide background as they go into their piece, but allow me just to give one highlight about each person here. Bill Mason is the Cuyahoga County prosecutor, chairman of the Great Lakes Regional Energy Development Task Force, and has played a critical role in the collaboration to develop Lake Erie. And thank you, Bill, for joining. Mario Garcia-Sanz. Mario is, I think, 1.5 months in Cleveland, Ohio, and he would like to share, but may not, how welcoming we have been in the Cleveland community and helping him get things set up like bank accounts, buying cars. We are an incredible society. Yes? Yeah? Did I get that right? He is the Milton and Tamar Maltz Professor in Energy Innovation. He's in our Electrical Engineering and Computer Science Department, and we more than welcome, and you'll understand why when Mario speaks this afternoon. Welcome him to Case Western. Thank you, Mario. Leo Russo. Leo is the Executive Director of the Green Academy and Center for Sustainability at Tri-C. We have had a real opportunity in this to develop the workforce, and Leo will not only speak to that, but has played an instrumental role in thinking about how, as we move through industry, we always also have the workforce developed for these industries. Leo, I'll say openly that a recent wind company looking at Cleveland looked through 31 community college sites and mentioned to me how impressive the millworking, the setup for the wind industry, the setup for the storage and manufacturing industry, what you're doing at Tri-C and how well you're doing it. So thank you for joining, and congratulations on at least that piece of it. Lori Wagner is president and owner of Phillips Electric Company. We have worked with Lori and also have a Right Project for Ohio funding in with him just now and the company. But he also joins us today as a member of the Ohio Power Siting Board, something in the state of Ohio which is quite unique to concatenate and collect all of the permitting foresighting of something such as wind into one organization. Lori, we are fortunate to have not only on that organization, but deeply involved in the development of wind in Cleveland. So thank you, Lori. Bob Savinell. Bob is the George S. Dively Professor in Chemical Engineering at Case Western Reserve University. He also is chairman, and this is awfully important to me and to us, of the Great Lakes Energy Institute's Technology Committee. We, as a Great Lakes Institute, will only deliver through deep motivation of our faculty here on campus. And thank you to Bob, who has driven and is driving the technical committee that will support assurance that we're driving research in the right direction. So thank you, Bob. And at the end of the table, a long way off from me, but not a long way off in the development of alternative energy in Cleveland, is Ronn Richard. And thank you as well, Ronn, for joining. He's president and CEO of the Cleveland Foundation. And as well, Ronn, I don't know the official title because I did not note it down here, but interestingly, he has been asked recently to head up the infrastructure team, committee, responsibility, decisions, I'm sure there's a proper title for it, for the state of Ohio. And as you know, there are two things that sit in front of us right now. One is an incredible list of projects and opportunities and decisions to make in infrastructure. The other one is an equal challenge, and that is the responsibility to use the money well, and we can't imagine a person sitting in that seat much better prepared to do that than Ronn Richard. So thank you. Thank you to everyone. And with that, I'll ask Bill Mason to get started for the afternoon.
Thank you, Dianne. My name is Bill Mason. I'm the Cuyahoga County prosecutor, and you're probably all wondering why the prosecutor is here. And usually that's the first question I get asked, so I'll get it out right away. Back in 2004, 2005, the OEA had a conference here in Cleveland at the Convention Center and did a pretty good job of laying out the case, if you will, for wind power everywhere. And I and one of my assistants walked over there one day. We saw it in the paper, walked over there one day and spent the afternoon there listening to Kathleen McGinty from Pennsylvania, the energy czar there, speak. And it ended up grabbing my attention. I ended up staying for the rest of the day and kind of got very interested in it. And then there was a lot of others interested in the Cleveland area who wanted to really look at the possibility of, and what that possibly was for wind energy in Cleveland. And so if you've grown up in Cleveland, Mario, you just got here, but if you've been here in Cleveland for any time period at all, you know there's a lot of wind. You need to walk downtown anytime, anywhere the wind is blowing. So we all got together and started talking about it, and we finally went to our county commissioners and said, you know, we really believe there's some potential here for developing wind energy. So the county commissioners put together a task force with members of our community, engineers, scientists, community development personnel, people in the industry, and we put together this first task force to just kind of look at the potential of the wind industry here in Northeast Ohio. Well, we did that, and we created the Great Lakes Energy Development Task Force, and we started looking at it. That was in August of '06. We wanted to really quickly come to a conclusion and see if there was something here to chase or not, and we were really looking at, obviously, the wind potential, the strengths of the wind. And then we talked, and we really kind of were thinking about what we should do, because the land-based wind turbines kind of industry is already kind of established, so we wanted to be bold and innovative, so we thought about offshore and putting turbines in Lake Erie. So we thought, and we discussed it, and we decided that was a path we wanted to take and blaze a trail to doing something of that nature. And the last, but to me most importantly, we saw and learned that very, very great potential for jobs. There's jobs associated with this industry. We've learned and we know now that Cleveland is so well suited to capture some of those jobs, capture this industry. So we then went to work. These very smart people, then me, went to work, and we kind of put together an analysis for the county commissioners. And we did that in about 6 months. We came back and gave the county commissioners our assessment of what we thought it was. And it was just that. We believe that there is obviously strong wind. There's great potential for this wind energy potential in Northeast Ohio, and all the things that Cleveland does well. were right here. And so we gave our presentation to the commissioners in February and told them that we really ought to take a look at this. With that, they blessed that thought, and we then went about looking for some funding to put together a study, because our recommendation was that we really do a fundamentally strong feasibility study on what that means for Northeast Ohio, looking at all the different things such as, the environmental impacts, all of the things that might be considered. Well, we stepped off that. The Cleveland Foundation, the Cuyahoga County Commissioners, Case Western Reserve University, and Nortec were the primary funders. We raised about $1.1 million and then went about a process of, sent out an RFP to get a developer or somebody to analyze the feasibility of it, to do the study. We ended up hiring UV out of Germany to come here, and they've been here now for about 13 months doing their study. They will, by the way, have just about completed it. 2 weeks from tomorrow at the Cleveland Science Center at 11 o'clock a.m., which is May 1st, 11 o'clock, there would be an announcement of the findings of the feasibility study. And we're all very excited about what that entails. I mean, there's a lot of things we hope it says, but certainly we'll wait for those results. But it's very promising for Northeast Ohio. At the same time, as we were going through this path, we partnered up with Case Western Reserve University, not just as a funder for the project, but as a partner to create a wind energy research center and help us decide and evaluate the proposals for the feasibility study. Well, we've done that. We've worked with them. We've obviously moved down the road a little bit along that. And we have now been working, like I said, on a pilot project. We believe that if we move forward on this pilot project in Lake Erie, that this will be the first freshwater wind turbines in the world. And we wanted to set the pace, set the agenda for offshore wind, hoping that all the different synergies that Cleveland has to offer would be used in this pilot project. And Cleveland then would become a hub of all these different things for offshore wind. We have been working very, very hard. We believe certainly that if in fact the study comes back to say that this is the direction we should go in, that there's some great potential here in Northeast Ohio. We've got deep water ports. We've got, the former we still have steel manufacturing here, but not like it used to be. We have the skilled workforce that for the auto industry and the steel workers who can do this kind of work. We have the forges and the plants that can be repopulated with the working population. For Cleveland, we got the rails that go from anywhere from the East Coast all the way to the West Coast. We got the water, the St. Lawrence Seaway. There's so many great things that are going on right here in Northeast Ohio to make this industry roar. But the best is it's already here. There are so many manufacturers of wind turbine parts in Northeast Ohio and in the state of Ohio. I think we've now isolated to be about 100 of them within Ohio and about 83 here in Northeast Ohio who are supplying parts to the industry. So we are moving forward on the premise that we are going to put wind turbines out on the lake. Our thought is that it will be between 2 and 8 turbines. We're hoping that the feasibility has moved forward, but we'll wait till it comes out and tells us that. We've been working very closely with Dave Matheson from Case Western Reserve University, who's one of the scientists here, who has really been hands-on. Him and Lori Wagner actually installed the testing equipment out on the crib and actually got into the wetsuits and dove into the lake and set them down. So I think they're looking forward to go back and pulling out the equipment. But the studies are what they are. They're information that we've never had and we'll be able to use in the future. The other component of this feasibility study was really to look at the feasibility of an applied research center in conjunction potentially with Case Western Reserve University and a test center to test the parts that will go into the turbines here in North America in the future. So that study will come back and lead us to some new paths and probably more study, of course, but certainly it's got some great potential. And we're been all very happy to see this happening. And as a result of all of this, and I think it really is a result of this pilot project, this study, all the interest we're bringing, there are many, many entities from around the world who are coming to Cleveland over the last 6 months, who are looking at Cleveland as a potential place to come to build their turbines. And I know Dianne Anderson has been working real hard and had one of them has really set the table for one of those entities to come to Cleveland and start doing business here. So there's a lot of potential here. We have also been approached recently by a couple other ones from Germany and from India and now from China, who are turbine manufacturers, who are now looking at Northeast Ohio as sites, potential sites for them to come here and set up shop, open up business, and manufacture jobs, or manufacture a business creating jobs for our region. So we're really excited about the potential, and we look forward to our next step. Thank you.
I won't do this between each one, but I would like to welcome Peter Buca. So Peter is the Vice President for Technology and Innovation in the Fluid Connector Group at Parker Hannifin. We thank you, Peter, for being able to join us and share the industry perspective on today. Mario?
Well, thank you very much for Dianne for inviting me to give this short presentation. I would like, well, just to tell a little story. Well, it was in Spain many years ago. Well, not many. It was 1992 in a little village that is Pamplona. I was working in that village in that town for more than 15 years, and being a professor at the university, and I was involved in many wind energy projects at that university. But anyway, there is this small town, just only 300,000 people. Yes, is the place of the running of the bulls. It's quite very well known in the world because of Ernest Hemingway. Anyway, in 1992, the main activity was just agriculture, some car industry, and some clinics, no more. Well, the government then in 1992 decided to start a new business in wind energy. So it's quite similar to Cleveland, to Ohio right now. And just in a few years, you can see that here are some of the projects. In 1994, they started new wind farms. They also did the first biomass electricity generation plant that was the biggest in Europe, in Southern Europe. Also, at that time, also the biggest European photovoltaic plant, 7.3 megawatts. And also they started many small hydropower plants. And the objective was to be independent, to be the first European region self-sufficient, in renewable energy. Right now, in this year, you can see there in that city the main companies in Spain related to wind energy. You can see, for example, Acciona is a company that right now has 5% of the world wind energy production. It's a very big company. And so with more than 6,000 megawatts installed, so with more than 200 wind farms. You can see also Gamesa Eólica is a very big company in the wind energy. It has more than 7,000 people working and more than 16,000 megawatts installed in wind farms with very low-cost machines. But the business was incredibly good. And you have M. Torres with, and the key point for that company is the technologies, a very advanced technology related to multiple wind farm or wind turbine design. You have others. You have the National Research Center in Spain, is in Pamplona as well. They started just 6 or 7 years ago and now have more than 200 people working there in wind energy mainly. And you have the Public University of Navarra. I was working there, and I was involved in many projects from the very beginning in this region. Navarra is right now the first region in Europe with wind energy. It has about 70% of the energy from renewable energy with more than 1,100 wind turbines installed in the mountains. And and I would like just for the discussion to comment my opinion about the successful strategy that this region has or had in the past, and the key points that I think, from my point of view, that was the key point for this success. I think that we can look at the picture from two places, from the government down and from the society and the universities up. So from the government down, for me, it's like there are like 5 rules, very important. The first one, 5 rules to create a new model that allow new companies to be in the region making business with renewable energy. The first one is the right to have the right of wind developers to connect the wind farms to the electrical grid. So if you are designing or installing a wind farm, you have to have the right to connect to the electrical grid. That's very important. This is the first point. The second point is this is not working. Let me see. No. Okay, it's very small. The second point is the legal requirement that the utilities must purchase the electricity from the wind farms. This is also very important. The third point is a guaranteed fair price for the energy. Usually, for example, wind energy is a little bit more expensive than the normal energy that is produced in hydro or is produced in thermal systems or things like that. So for that reason, the government put a little increment in the price, and the government is paying to the companies there, not just only in Navarra, also in the Spain or in many other countries in Europe, is paying a little more money for every kilowatt hour. Well, with these 3 first points, you can design a model, to attract new companies to your area to make business with energy. It's also very important, number 4 and 5. Wind generators pay the cost of connection to the grid, but at the same time, the grid operators pay for additional expenses required for grid updates. So this is the model from the government point of view. Now, from the university and from the society, every dollar that you are putting in renewable energy is activating research, activating new ideas in energy innovation. With these ideas, you eventually can produce new patents, and with these new patents, you can help existing companies or start new ones, and then creating new jobs, activating the economy, helping to recover from the crisis, increase the energy independence is also very important for the country, help the environment, and reduce the global warming. So everything is starting with dollars and ideas, and then this is, from the university and from the society up. So if you put all together from the government and from the society and the university, you can have this new market, the renewable energy market. Just some ideas that Bill Mason explained us very well. If you look right now at the potential wind energy jobs that we have in Ohio are more than 80,000, because we have many good companies working in other sectors, but with some conversion, it's very easy to work in areas, for example, in wind energy, with blades, rotors, controls, towers, foundation, electrical generator, power electronics. We have these things here in Ohio. At the same time, we have a Lake Erie, just one number. The total wind energy already installed in the world right now is 100 gigawatts. Only Lake Erie has 68 gigawatts. So it's huge. The potential wind energy that we have in the lake is huge. We have also, the university. research centers, NASA Glenn, other universities, companies. We have the support of the Ohio government, the Cleveland Foundation, or the Cuyahoga County or City of Cleveland, or many other institutions. If you put all together, and we think in a strategy similar in some way, that this strategy from the government down and from the university and the society up, we can create here, one of the biggest areas in renewable energy in the world. This is my understanding. Well, we have just started, I have just started here, at CASE, and this is my main area of interest. I have been working with, designing wind turbines for many years and applying advanced control to these systems, to very advanced multiple synchronous generators, and also working in grid integration problems and things like that. So this is the main activities, the main area of my group will be this here. And the areas that we are right now starting, I think there are 5 very hot topics for research for the future. One is advanced control system for optimum efficiency and high reliability of wind turbines. This is a very hot topic. Another one is health monitoring. You can realize that if we have many wind turbines working, we need very good techniques to know what is going on in the turbines. And this is a very hot area also right now for research. Another one is new blades concepts and the control system for that. As far as we are increasing the size of the wind turbines, that is very easy to do in the lake, because onshore is another problem. Onshore, the limit is about 45 meters, and it's because of the roads, because of the, you cannot transport these huge blades more than 44, 45 meters. But for the lake, we can put anything, we have not these limitations. But then the limitation is a physical limitation because of the structure and because of the interaction of the structure with the control system, things like that. So this is another hot topic. And the other 2 are control system for grid integration. So if we have more and more renewable energy connected to the grid, we have to deal with that. This is a hot topic in Europe right now. There are countries as Spain, for example, with 15% of the energy is renewable energy, Denmark 20%, Germany about 10%. So this is a hot topic because we have to control these new systems in the grid, and how you have to know how is the interaction between these systems and the grid. So this is another hot topic. And the last one, very important for Cleveland, is offshore wind technology. That it means new deployment vessels, new foundations, new blades, new system to coordinate many windmills in the middle of the lakes, things like that. And just this is the last slide, the roadmap. When we are talking about new energy systems, we need new engineering concepts, from research centers, universities, companies. But then we have to deal with economics. We have to deal with reliability. We have to deal with efficiency. We have to deal with certification. We have to certify the process that we are designing. We need to fulfill regulations. Probably I know that there is very little about regulations here in Ohio for offshore, for example. So we have to work very hard in that. We have to deal with implementation, manufacturing, new companies here, new processes for that, seating, installation, how to install a windmill in the middle of the lake, things like that. Then marketing, that's very important. You can destroy a project just because of marketing. This is very important. Then interaction with the grid, interaction with environmental, and maintenance. So there are many, many different problems, and I think that we have to work in all these areas to be successful in energy. That's it. So thank you very much.
That's not my presentation. No PowerPoints for me today. A little tired of PowerPoints. The industrial perspective, and let me represent that in a few minutes with you. With Parker Hannifin. Who knows Parker Hannifin here? Who's heard of the company? Well, that's fantastic. I've never had that kind of response from an audience before. But being in Cleveland, I would assume, and I see Larry. Larry, I know you'd raise your hand, okay? in Cleveland, we're known. We are known also with our customers. We're not that known outside the world. If you want to understand Parker, think of the society we live in as a human body. If that's a human body, then Parker supplies the muscles and the veins and the arteries that make that body run. That's really where our specialty is, okay? So I've long been an advocate of alternative energy, and I want to talk today about how that works in an industrial setting for us. Where do we see the profit in alternative energy? Where do we see the profit in energy in general? I think the alternative issue is not that important for me. Energy in general, Parker regards as the most important need of mankind. If you've ever heard the term the top 10 needs of mankind, it's a list that was compiled by a professor at Rice University. Unfortunately, he's now passed away, but these needs were energy, water, democracy, freedom, all these different interesting needs. Parker likes to align our products to those needs. If those needs are met by humanity, they're going to always be here and we'll always be in business, okay? What's interesting about that list, though, is that water is very near the top of that list, and energy is not too far from water. But if you have enough energy, you can make all the water you want, right? Food's on that list, too. If you have enough energy and you can make all the water you want, is food really a problem for you? Not really, okay? So of all those needs, energy is the supreme need. And energy has a lot of different forms. Of course, we use oil now as our main energy source. And that's not going to go away, by the way, anytime soon. Oil is the main energy alternative, the main alternative right now. But no matter how you generate the energy, it's still going to be transported, right? There are still vehicles that are needed to transport fuels to the person who is making the energy. There's needs for taking the energy away. Parker-Hannifin supplies power cables for offshore wind turbines and for onshore devices, okay? We supply the devices that turn the wind turbine blades to face the wind. We supply devices that find oil, okay? Hoses, connectors, seals that enable all that energy collection to be possible. So we see our interest involved with energy. Our future best interest is in serving the energy markets no matter where they're carried. And we've always been an advocate for alternative energy. Now, why is that? About 10 years ago, I had the chance to be on a study committee, something called the Ohio Business Roundtable. And we were looking at how power is so important for Ohio, power being gasoline engines, gas turbine engines, and electricity. And oddly enough, Ohio has been the prime innovator in the world in all those sources of power. And we talked about wind. In that committee, we had General Electric there, we had American Electric Power there, we had, I think Benson, you were in that committee. We had SOFCO there at the time, a different name, but all these parties were there, and we started talking about the wind energy problem. And I had the chance to study at that point in time. And what I learned was that what we thought was an advanced technology at that point in time, 10 years ago, that was actually seeing good commercial success even 10 years ago, was very primitive from an engineering standpoint, okay? The technology had been developed and really left unadvanced for many, many years. As I've grown at Parker-Hannifin, and I've been there 30 years now, I've done a lot of work in the oil field, I've done work in transmission of liquid natural gas, I've done work in virtually every aspect of energy there. I'm continually amazed at how poor the technology is that we devote to the harvesting and the transportation and collection of energy. So from an industrial perspective, what does that mean for me? It means that there's huge opportunity for me to innovate in that space. It's one of the prime reasons why I've identified energy back in my divisions as being one of the areas I want to focus on to bring new products to, okay? We've been very successful in the last 5 years in bringing out new products in that space. And this wind turbine issue is critical for me. So what's missing? Why is technology so poor in energy, right? It's generally the lowest cost technology that's deployed. It's mass scale technology. And in particular, let's talk about wind turbines for a second. If all this great technology is out there, the space program, these incredible hydraulic systems we use to manipulate trees and to harvest farms, why isn't that being deployed in wind energy to make that task better, okay? There's no pressure for it. Frankly, in a word, there's no pressure to make it better. It's good enough right now, right? Another thing missing is there's really no thought leadership. There's no center in the world that drives thinking to new heights in this topic area. It was never on the public's mind to a degree where we thought we should devote resources and our best minds to it, right? Where were our best minds? I would hope they were not devoted to finance. okay? And I think that the history's revealed that's not true. Our best minds were not in finance. But I think one role that CASE plays here that's really going to help drive the industrial value and really create an enormous amount of value that we're going to turn into jobs and into future success for this area is this idea of thought leadership. You know, Mario puts up this thought about, it's not just about the wind turbine. It's about how to manage fields of wind turbines. It's about how to manage the power flowing in from all those during all circumstances during the year, right? Throughout the entire condition of the environment. How do you think about that? Where's the thought process that defines what the future will look like in that region? At Parker, we have a process we call, what does good look like? Who will write that story for wind turbines? The people that write that story will generate the value that we can all collect on as a society. And if that's done here in Cleveland, Cleveland will remain a key center for thought forever for that topic area, okay? This same problem applies not just to wind turbines, it applies to energy harvesting, oil collection, it applies to gas turbine engines, which NASA has a big leadership on in thought process there. It applies to every aspect of energy that we talk about, solar included, okay? Have you thought about what the world's going to look like in 30 years? Have you given that much thought? Beyond worrying about your retirement, that is, okay? You know, when I look ahead that far, and I try to do this on a regular basis, it hurts my head, but as I tell my daughter, correct thinking should hurt, okay? If you're really thinking, it should hurt a little bit. I don't see a world where all of our energy is generated by wind turbines. The world's not going to have all of our energy generated by solar, or by nuclear, or by oil. It's going to be a mix of all, okay? So we have to step even beyond the wind turbine bit and say, how is that going to interface with a hybrid or a heterogeneous, seriously heterogeneous? Today we have a homogeneous energy picture, but a seriously homogeneous energy picture, how does that all work together with the different limitations of each method? Who's going to think that through? And if someone does think that through, what treasure lies under that solution, okay? Parker is a Cleveland company. We started 90 years ago when our insane inventor, not insane, he's a little crazy, but he actually thought he could reinvent the truck, okay? He thought that if they used air brakes for trucks, it would enable trucks to be bigger and transport more over the road than current trucks. What a crazy thought. How could that ever be successful, right? Arthur invested his entire life in the solutions that came from those ideas that he had, and it all started with Arthur talking to people like Charles Lindbergh, like the trucking people, like the other industrial magnates at the time, and it happened right here in Cleveland, okay? Cleveland's always been a center for thinking. So Parker's very lucky to be here, and we intend to pursue that same kind of avenue that Arthur did when he started our company to things like alternative energy and develop more value for this area for that and for ourselves, of course, okay? It's in our best interest. Any questions or later?
Yeah, questions.
All right. Did you miss the PowerPoints? Okay.
Thanks.
I'm still dependent on PowerPoints. I'm a teacher after all. Have you noticed that the discussion of research in renewable energy very quickly turns into a discussion of economics, which very quickly turns into a discussion of employment, and from my perspective, very quickly turns into a discussion of training. So that's what I'm here to tell you about today. The purpose of this panel is jobs for every level of the labor force. And we're doing those kinds of things in Cleveland, training people for what has become a familiar term, the green economy. If you could graphically lay out the world of training, in the center is credit traditional degree training, whether it's an associate's degree or a bachelor's degree or a graduate degree, the traditional path that most students and most of us have followed. On the edges of those of that core is, on one side, professional development, the kinds of training that we go to enhance our existing employment, to upscale our skills. At the other end of that spectrum is workforce development, getting people who don't have skills, enough skills in a very focused and a very concentrated way to get them employment. And we've been trying to do all three of those things, and in a few minutes you'll see why there's such a strong relationship between a research institute such as Case Western Reserve and a technical community college like Cuyahoga Community College. First, to slightly reiterate what most of you in this audience know, the economic potential, and it almost looks like it's coordinated. I'll focus on solar photovoltaic for a moment because there are a number of different economic and employment potentials here. Renewable energy has a potential for 9 million jobs in the economy now. The real potential, and we need to look to places like Germany, is that we could have many more times the employment in renewable energy and energy generation than we do right now. One avenue is photovoltaic energy generation, one of several. This chart is a little too busy for you to really see, but you see employment based upon the existing Ohio portfolio with employment potential for this part of the state in the thousands. 3,500 people in a few years, simply in photovoltaic support. It's interesting how difficult job and economic data in the green economy is. There are many studies very well done on a national level. There are even a number of very decent studies on the regional and state level. There are very few, if any, at the local level and county level. And we've tried to really zero in on specifically that because that's really our service area. Photovoltaic has a lot of promise because of recent advances in membrane and in materials development and in energy storage. It's moving very quickly. We have a class that we're teaching people how to install photovoltaic systems right now, and there are still some brackets and bolts, and we're preparing our next generation of training to teach people how to paint the photovoltaic membrane on shingles. This is a picture of what it could be. This is a picture of the world's largest wind farm, and it isn't in northern Ohio or in the United States, it's in Germany. One of the, I guess you could call it, fairly naive objections to solar power in northern Ohio is that we don't have much sun here. Northern Germany has 3.8 hours of sun a day. Northern Ohio has 4.2 hours of sun a day. So for a country of 80+ million people to have a large percentage of their renewable energy generation from the sun, it makes it a very realistic possibility for this part of the world. So Germany's already very far down the path of employing quite a few people through the implementation of solar. What kind of training? That's a shot of people going through their NABCEP certified photovoltaic training. On the one end of that spectrum, the professional development training is here. Everything from renewable energy to green IT to green entrepreneurship, which, by the way, I tried to buy some curriculum in green entrepreneurship, and it didn't exist. It doesn't exist. So as one element of our cooperation, we have engaged a professor from the Weatherhead School who's writing probably the first known green entrepreneurship program. And there are some unique features to that concept. On the other end of that spectrum is workforce development. People who have base skills or for whatever reason are unemployed to get some jobs in the green economy. At first, that was a difficult topic for me to try to grasp until when I started into sustainability, I took that mandatory pilgrimage to Northern California and San Francisco and Berkeley and found somebody from San Francisco State, a Raquel Pinderhughes, who is really the curriculum writer for Van Jones, who has that book, The Green Economy. And she was the one who told me why the green economy can support jobs for people who are now unemployed. And we can get to that in a second. So there is a program, actually this is our second day of selecting students, first cohort of 40 people that will start in Cleveland next Friday, where we're going to train unemployed people to some specific jobs in the green economy that exist today. One of the biggest differences between our program in San Francisco's is that we're focusing on 4 job categories that have employment today. San Francisco is training for 22 different job categories. Most of them have employment possibilities in the future. And unfortunately, Cleveland is in desperate shape, and the people that we are seeing these next couple of days need some jobs now. It's a 3 academic level program of developmental programs in math and reading, technical programs in everything from measurement to hand tool use, and then a 3rd layer of certifiable skills. We're going to concentrate on solar, deconstruction, wind components, and energy efficiency or weatherization. The picture on the right there is an old school called Notre Dame Academy on Ansel Road. It's now a Community Development Corporation, and that's where we're going to have the training. Because even though Tri-C is a community college and has a campus downtown, that's a very intimidating environment for many people who haven't been to school for a while. And the people we're going to have in this program, for the most part, haven't been to school for a while. That first cohort of 40, if tomorrow's interviews hold through, we'll probably have 10 or 12 people who are living in homeless shelters. So these students need a very warm and friendly environment. We're going to have a non-sequential curriculum. By that I mean they'll learn an hour of math and then learn an hour of measuring and then learn an hour of how to install a solar panel. One of the big problems in many schools is we lose a lot of students through the remediation process. If somebody wants to be a nurse and would really enjoy the nursing clinicals, by the time, if their math isn't good, they get to that enjoyable class, they have to go through 5 or 6 horrible math classes and learn algebra and that can really be agonizing, and you lose quite a few people. So we have the option of teaching them what a fraction is for an hour, and then giving them a ruler and showing them what a fraction is, and the value of a 1/16 of an inch when you cut 2 pieces of wood at an angle, and then teach them how to install a solar panel and how to orient to the sun. So it's been a very interesting educational experience. So we have a lot of new innovative programs within this workforce development pathways to green jobs. It's interesting that it is funded by private foundations. So far, we have 4 or 5 requests out, and the 3 who have decided positively. The Gund Foundation and Charter One Foundation and Living Cities Foundation. So it's a privately funded program that's being put together here. Really heavy case management because we want to make sure that we keep people in the program until they're done and be able to place them with green jobs. By the way, you know, there's almost always the question, what is a green job, and is there really a green economy, and is there really something that's different or unique, or are you just redefining? And there is really no one answer. Some of our employers are machine shops that have made the same exact parts for 30 years. The fact that their customer now is Vestas makes them part of the green economy, but the skills are the same. Then in the center, the photovoltaic installers are part electricians, but there's some new technology and there's some new design and there are other technical skills that they need. So that's a hybrid. And then there are some jobs that are totally unique, associated with new materials and new methods and new delivery. So anything that qualifies as a green job is what we're going to place people in. One of the important educational concepts today is to have third-party certifications. professional associations, certifying, training. It buys a little bit more of an interview when you go to a Parker Hannifin or an Eaton or a Mariner Energy for photovoltaic. And we have a number of certifications, and some of them in renewable energy there. And I think I've gotten my PowerPoint fixed for the day, so thank you very much.
Figure out how to use this.
It doesn't look like his.
Nope, not mine.
Do you want to talk about that one, though, Lauren?
Yeah, I'll talk about whatever you put up there is good. First, I want to thank Lindy and Dianne for inviting me here. This is really a great honor to be part of this panel. And I would like to thank two of the panel members for them really being responsible for me being here today. And I don't know if Ron Richard remembers or not, but back when they had their crazy ideas about a wind turbine at the Great Lakes Science Center, Linda Abraham Silver called me up and said, "Are you interested?" And I says, "Well, I better think about it." And after 24 hours, I said, "Sure, let's do it." And we were very fortunate to have a great team, and for us, our company, to be given that opportunity to excel. And I want to thank Ron for that. And I also like to thank Bill Mason for inviting me to be part of the Great Lakes Offshore Task Force. And that has really given me a good opportunity to understand more about the business, to become more involved with CASE, and also I think both of those things in large part helped me get appointed to the Ohio Power Siting Board. And for those of you that don't know what that is, since 1972, every power project in the state of Ohio, doesn't matter what it is, every power line, every gas transmission line has to go through a very tortuous process of evaluation. I was appointed as the public member. The other 6 voting members are head of the different agencies, the EPA, ODNR, and things like that. So it's a great process. It works well, but renewable energy to this point has not been part of that process. As of today, there are no power projects from wind, solar, biomass, or anything else like that. Now, that certainly is going to change within the next 6 months, but it's a very interesting process. Just to give you a little bit idea of my company, and then I will get in a little more into the research side of things. We're basically a company that's been around since 1946, and we do a lot of different things. Some of the things that we've been privileged to do is, we developed a, we sell our service. We don't manufacture anything, although we will build something. So we developed an explosion-proof control system for a channel boring machine. We had 5 weeks to do that from design to build to ship. We developed an axial flux electric motor for DuPont. We got 14 months to do that. We developed a SCADA system for Ashland Chemical, developed a world champion offshore powerboat racer. We designed and built that in 1992. And then that's our one attempt at being a manufacturer. We designed a beautiful product. It was engineering driven, and I'm sure Pete can tell you how successful engineering driven products are. Nobody wanted to buy it, but it worked really well. We got involved in the renewable energy business basically around 1999. We did a hydroelectric control system. On the bottom, you can see in the center the Great Lakes Science Center. In about 2002, we did a safety control system for a nuclear reactor. And then there's 2 other projects that are in the works that we can talk about later. Basically, the company is divided up into 7 groups. Pretty traditional electrical contracting, electric apparatus, drives. A little more interesting, applications engineering, solving problems for our customers. usually a one-off solution. Someone will come to us, can you solve the problem? Sure, and we solve the problem. A little bit of process automation, pretty traditional things, mostly process control, liquids, powders, things like that. The two things that are really exciting and what has driven our business over the last several years is the renewable energy field and underwater resources. As far as our involvement with CASE goes, starting in '99, finally got Joe Prowl interested in something we were doing, and this was for the hydro project, and we wound up having several of his students as senior project. It was our capstone project, and we had some good involvement with that. Then in '07, I was fortunate to meet Dr. Matheson and Dr. Alexander, and we started talking about offshore wind and tried to think of some different ways to collaborate, and that really led into 2008, where Dave Matheson and I are out on the crib in the middle of winter, taking laser measurements of the wind profile on the lake, and getting our feet wet, so to speak, in what we need to do in the future to make offshore wind a reality. The most interesting part is that you go out there thinking, we're going to figure out how to put a turbine up, and you come back and you go, wow, this is just like being back in college, boundary layers, and you know, this is the real fluid mechanics stuff. And that was a lot of fun. And for me, being in business, being able to plug back into the university like that was a tremendous experience, and we're just starting that. The next one is the ice thickness measurement. We placed a device on the bottom of the lake, and sooner or later we got to go back and dive down and bring it up, and that's going to help us determine an awful lot about ice engineering, what we can do for offshore foundations, how to build them so they last, and then how to build them so that they're a lot less expensive. And finally, the last piece that is in process right now is that we have a third frontier proposal between a number of industrial companies in Cleveland, as well as the Energy Institute and the people associated with that. And we have absolutely the best proposal out there, and it's just a matter of whether or not we bring home a winner. So we've given it our best shot, and thank you very much.
Well, it's a pleasure to be here as part of this distinguished group and a great audience out here. My name is Bob Savinell, and I'm with the Great Lakes Institute for Energy Innovation. And I certainly want to congratulate you and Alexander and Dianne Anderson for the tremendous leadership they've been giving this institute over the last year or so. Diane's actually been here less than that, but I've been brought on sort of as the chairman of the technical committee and has electrochemistry, but it's actually the technical committee of the Great Lakes Institute. And I'm sort of their spokesman for the faculty and sort of the touch point to bring faculty input into the Institute from a broader perspective. And so I really want to talk about three things here today. One is a little bit about what our strengths are in energy research, and in particular in the area of electrochemistry. I do want to talk a little bit about the role of the university in research and education, and then I'm going to highlight that with a little bit of an example of a success story that we've had. So let me first of all talk about the general research thrust. In energy research, in Case School of Engineering, I'd say about 60% of the faculty are somewhat involved in energy research in areas of materials, systems, control, integration of materials and devices together to create energy type solutions. And broader across the university, there's many, many more than that 60%. By the way, 60% in Case School of Engineering translates to about maybe 60 to 70 faculty members. So if you look at the broad areas of research, I put down here, Mario talked a little bit about wind, but he also sort of integrated that a little bit into smart grids and power informatics, the bringing these things together, these solutions together. Energy efficiency is an area that we deal with, as well as carbon capture and sequestration. And I'm going to talk a little bit more about storage and fuel cells as a storage device, energy storage, and then fuel cells as energy conversion technology. But before I do that, let me first of all say a little bit about the strength this university has in electrochemistry and electrochemical engineering. It goes back quite a few years to Frank Kavorka, who is Professor Ernie Yeager's advisor, and this is a picture of Professor Yeager, probably goes back in the maybe in the 80s. Professor Yeager passed away several years ago. But he really brought electrochemistry to the forefront of this university and created it as a significant entity from around the world. There's a global view of Case being the center of the universe in electrochemistry. And, you know, some people may argue about it, but there's very few that have significant grounds to argue against that. There's about 30 or so faculty who have primary research interests in electrochemistry on this campus, probably 60 to 80 graduate students and research associates, to give you an idea of the scope. There's a strong emphasis on collaborative research within the center. And just to give you an idea of the impact the center has, just within the last 2 weeks, there was an article that was published that reviewed the Journal of the Electrochemical Society, which is the premier journal in electrochemical publications. And the Journal of Electrochemical Society reviewed the publications since the very beginning of the journal, which goes back into the early 1900s, I believe. And they looked at the number of publications and the number of citations in there and how they were distributed. And it turns out that, first of all, Case is number 12 in terms of the number of publications, papers that have ever been published in the Journal of the Electrochemical Society from the very beginning. And that's just with the names of Case associated. That does not include all our graduates who have gone on, who are working at different companies and different organizations that are still publishing in that journal. Matter of fact, you go to an Electrochemical Society meeting, you'll find out probably 25 to 35% of the participants have some sort of connection with Case. The other interesting thing is they also looked at the top 100 publications that were cited the most over all years. 3 of them are from a current Case faculty members. Number 3 of all the 100 is a Case faculty. That's Tom Zalazinski. So I had to mention Tom. It's an indication of the impact that this field has had on a global level. So let me turn to the next slide on energy storage. I won't put too many graphs and equations out there for you, but this plot here I put up here is called a Rigoni plot. I put it up for 2 reasons. One is David Rigoni was a former president of the university here, and he's the one that developed this way of presenting power density versus energy density. And it shows all different types of energy storage systems and where they are strong in terms of specific power versus specific energy. And you'll see there on the left, very high power, you have things like supercapacitors and advanced flywheels, but they don't store a lot of energy in terms of capacity. And all the way to the right and lower end is fuel cells that have very high energy densities, but don't necessarily have the high power densities. Okay? So what we got to do is the people that are working on the left are trying to move themselves to the right, and the people that are working on the right at the bottom are trying to move themselves up in these technologies. I just want to mention a couple areas that are going on here at Case. A lot of the work we do is the material science area that integrates into these devices that make them higher performing. Okay? So one area is in the area of supercapacitors. Now, not that we have a lot of strength at CASE in supercapacitors, but we have a lot of strength in materials that go into supercapacitors. But we actually have a person in the Cleveland area, John Miller, who's world-renowned in supercapacitors. So we've been working together with John to develop the technology or help them with problems that we can solve as a university addressing these issues, but we're also looking at how do you test these things and trying to create a testing center for these large capacitors. And Megajoule is another local company that's actually trying to commercialize these supercapacitors. They're working with us also in developing a testing capacity, a testing system to do this. In another area I want to mention, highlight, is in the area of batteries. And you see lithium-ion batteries in there, and they have they're sort of in the middle in terms of energy density and energy capacity. And of course, these are the type of batteries that are going to go into your electric cars, your plug-in hybrids and that. And the whole idea is how do you create higher power density, higher energy density systems. So there's a proposal that went out of this university a few months ago to the Department of Energy for one of these engineering frontier centers, a new program for the Department of Energy. It looks at novel concepts that are broad-reaching, paradigm-shifting things. And the whole concept here is how do you use molecular synthesis principles to build nanoscale battery systems that you can connect together electrically and chemically so you can create a very, very high energy density system. And so there's very novel ideas and techniques and areas that are going into that type of proposal that have been actually already submitted. Now let me talk just a few seconds on fuel cells. We have quite an extensive history in fuel cell research on this campus, and we have some organizations that sort of try to facilitate the research in fuel cells. One is the Case Advanced Power Institute. The second one is the Yeager Center for Electrochemical Sciences. I already mentioned the strength of electrochemistry on this campus. And the third area is the Electronic Design Center, which microfabricates and helps us come up with novel, innovative ideas on making devices from advances that come out of the materials and systems understanding from the other areas. The range of research in the fuel cell area, it goes from very fundamentals, aspects of electrokinetics, catalysis, and issues like that, through new materials, into systems and modeling of these systems and bring them together, new designs, paradigm shifting type designs, and actually addressing research to go into various type of applications. So the scope of research is very broad, from very fundamental all the way through applied. Now, let me just talk about what is the research model, what is the mode of operation of the university. You know, our mission is actually to educate and to find new knowledge. So we have this value chain, research value chain at CASE. It's probably true of many other universities. And it starts at the beginning with ideas that are coming in here. And you can see what drives the ideas that faculty work on, okay? Some of it is due to scientific and engineering community in response to government studies, industry needs, that they define problems that we have to work on. Some of it's just pure curiosity, okay? A faculty member and a student sitting down trying to figure out, why is this happening? What can we do to try to understand that better? And you know something? A lot of those pure curiosity-driven research is really what comes up with the new breakthroughs, the new insight, okay? And that's an extremely important thing. But you see, those ideas come in, and students and faculty work on these ideas. And they have enablers like seed funding to develop the ideas, equipment, facilities, fellowships, new faculty coming in to bring in new ideas and new approaches to solving problems. And then we have to have funding to pursue these things. But the outcome that comes out of this is knowledge transfer. And knowledge transfer is not just papers, but graduates, okay? Because when our graduates go to work at Parker-Hannifin, they're bringing something they learned from new areas of research with them. So it's a very powerful way of doing technology transfer. But we also have the path going through intellectual property. startup companies or licensing the technology and developing into new markets. So let me go through a quick example of what I like to consider sort of a success of this model. And this is a case study of a high temperature PEM membrane that we worked on a number of years ago. Okay? The need was defined as how do we improve these direct methanol fuel cells? And we said, let's raise the temperature. Well, we can't raise the temperature because polymers don't go up that high enough in temperature. We said, well, let's invent a new polymer, a new way of doing that. So we proposed to DARPA a couple approaches. One of them actually worked out to this chemical compound you see here that the polymer itself was made by hexylanese, but we learned a way of doping it with an acid to make it conductive, so it worked in the fuel cell. We had the first publication in 1994, the first patent in 1996, and the advantages of this type of technology could lead to simpler, smaller fuel cell systems and to enhance tolerance to impurities. That was the basic advantages of it. Well, because of that project, we've educated 14 postdoctoral students, 8 PhD students, several master's students, several visiting scientists. And you say, well, okay, so you educated some people. Well, these people are now working all over the world in the electrochemical area. But it also led it to a global effort on trying to develop a high-temperature membrane for fuel cells. Before this time, nobody really thought it could be done. This is a plot that came out of a recent publication just within the last 2 weeks. And what it does is it shows the number of published items that was searched on the Web of Science since 1995 that covers the topic of polybenzimidazole in fuel cells, the essence of this invention. And it shows that, you see the exponential growth, it's over 250 publications now growing out of this one set of publications that came out of CASE in the early 90s. It also has 6,000 citations on that work. So you might say, well, so what? So you publish lots of papers and you have lots of citations. Well, we also have several patents on this technology now. And we have non-exclusive license issued to 5 different companies. And 3 companies have pre or commercial products. One license went to BASF. At that time was hexylanese. Now they split up a company called Pemias. Now it's part of BASF. And they're actually producing commercial products of PEM membranes and electrodes built up together. A second license went to Volkswagen, Das Auto, and just recently they announced not too long ago that they have a high temperature PEM fuel cell for their electric vehicle. And just recently, within the last couple of weeks, we negotiated a license for the Danish Power System, a small startup company, well, it's a small company in Denmark that has developed a different way of making this PBI polymer and making new types of membranes. So we're all very excited about that collaboration because that's a collaboration in which we get to share in their intellectual property as well. So finally, let me just summarize by saying that being competitive in energy, there's strengths at CASE that puts us in a strong position. We have strong technical strengths in the area of electrochemistry, materials, design, fabrication, systems and controls. We have broad range of expertise. We have organizational strengths here, motivated faculty, a really committed university administration here, and experienced leadership. And the quote at the bottom, I'm not exactly sure who actually came up with the quote, but it really refers to Dave Matheson. It says, no fear, start where you are mentality. A couple of years ago, we didn't have much in wind energy, but now Dave stepped up to the plate, had no fear, and now he's actually exhibiting leadership across this region in wind power. And so I think that's sort of a sense of the type of faculty we have here. We are strong and good in lots of areas, but we don't hesitate to step to the plate to meet new challenges too. Thank you.
Good afternoon. Still awake? I'm sure you are. These have been very good presentations. I specifically asked to go last because I thought I would have the least to add to this discussion. I am very proud to be in this company today. The Cleveland Foundation has perhaps a novel approach to philanthropy. We believe the way we can be most effective and most impactful in helping our community thrive economically, which is, of course, the basis for us thriving socially and in every other way, in the years ahead is to catalyze new industries and new institutions. We feel our key role is to lower the risks for the public and the private sector to come in and do their job. We can take bigger risks than the public sector because we don't have to worry about being reelected. We aren't hampered by bureaucratic rules because we're part of an organization that started 100 years ago, even though we are part of an organization that started almost 100 years ago. We don't have the press watching over us with the level of scrutiny that the public sector has because they're spending the public's tax dollars. And we can take more risks than the private sector because we don't have to be concerned about quarterly profits or shareholders. And so, not that we don't have good oversight, but we can do things that are really, really, really early stage. Of course, even a foundation can only take this approach if it has a bold and a high tolerance for reputational risk board of directors and a staff which has the talent and entrepreneurial spirit to make these things happen. And fortunately, we have both. And I'm happy to see Benson Lee, who is a longtime board member of the Cleveland Foundation in the audience today, who has been amazingly supportive of all of our risk-taking. I arrived about 6 years ago, almost 6 years ago, and the board had said to me, please make economic development the Foundation's #1 priority because everything else rests on that. Our wonderful arts and culture institutions, the Cleveland Orchestra, the Art Museum, etc., can't thrive in the future. If the economy is not thriving, there won't be an audience. They can't financially maintain themselves. And so with economic development as our top priority, the first question I had for myself and the foundation was, what is the blueprint for economic development for Cleveland? And we didn't see any. And so we started to ask ourselves, what are the new industries of the future that can sustain Cleveland like the industries of the past that made us the great city with the world-class educational arts institutions that we are today? And it occurred to us that certainly advanced energy could be one of the keys to Cleveland's future, along obviously with healthcare, biotech, et cetera, but that biotech had a pretty good start with the Case Med School, the Cleveland Clinic, UH, et cetera, and that where we could really add value maybe was in advanced energy. And I should note that there are 717 community foundations in the United States, another 700 plus overseas. We were the first, founded in 1914, for those of you who didn't know that. And we were the first to have energy as a major focus of our work, and we're still the only 6 years later to have energy as a major focus of the work of the Cleveland Foundation. In all, we have a commitment to helping Northeast Ohio become a national and international center for advanced energy, R&D, manufacturing, licensing, and export. Like everything in economics, it all starts with education, and so we start with education as well. Starting at the lower levels, before I talk a little bit about our relationship with CASE, we support workforce development. We support the STEM schools that have recently been developed here, science, technology, engineering, and math. We founded the Cleveland High School of Science and Medicine, our own version of the Bronx High School of Science, which is just across the street here in John Hay. And I co-chair that with Frank Sullivan, a board member of the Cleveland Foundation. And we are now starting the Cleveland Center for Arts and Technology, which will be a workforce development educational institution that will both help adults who've long since left school or dropped out of school, coming back for training, and at-risk youth that will come in after-school programs. And we think that certainly energy, green jobs will be one of the tracks in this new institution that we're starting right now. We're actually, completing our search for a site and executive director in the next few weeks. We've been very involved in public policy, very involved in helping to get the RPS bill, the Renewable Energy Portfolio Standard Bill, introduced and passed in our legislature, something we thought was absolutely essential for us to be able to compete, since 26 other states had RPS bills already passed, and that was fortunately passed. Starting almost 6 years ago, we began with this premise that maybe energy, in particular wind power, but not just wind, could be a major component of our economic future. We started out in 2003 by paying AWS True Wind out of Boston to do a wind map of Lake Erie to see if we had good wind, and then helping to put monitoring devices out on the Coast Guard crib, our water intake there. In 2005, we hired Richard Stubbe as our BP Fellow for Energy and Environmental Advancement. I think almost all of you that are very active in this field probably know Richard. He's been everywhere and I hope very helpful. We helped with great partners, Phillips and others, to get the wind turbine erected in front of the Great Lakes Science Center after Linda Abraham Silver called and said, "We love what you're doing in wind. We'd like a demonstration turbine in front of the Science Center." So we're really happy to partner with the Science Center on that. Then, of course, as Bill mentioned, we were very, very happy when the county expressed interest in playing the lead role on the wind turbine on the lake project. And I just have to say that Bill and Steve Deaver have done a magnificent job. I also first said, why is the prosecutor leading this? But it soon became apparent that he's the utility player. And so it's just been wonderful to partner with the county on this. We helped get solar panels in front of the Science Center and on what was then Jacobs Field, now Progressive Field. More recently, we helped to start the Carbon Fund for Cleveland, one of the few cities, if not the first maybe, to have its own carbon fund. And recently, as was mentioned, the governor appointed me the infrastructure czar. First, I've been working on roads and bridges, but now I've been asked to turn my sights to energy and look at all of the things in the bill where we could get funding for the state of Ohio in competition with other states. I'm working on the competitive and discretionary grants, and we'll be working very closely with universities to help us get hopefully more than Ohio's fair share of these discretionary competitive monies. In terms of economic development, already we're also the only community foundation in the country to have a program director for international relations who works very closely with our program director of economic development, who's here actually. Shilpa, would you take a bow? Shilpa Kadar, program director for economic development, who works with Richard Stubbe and Jorge Delgado, who's our Director for International Relations. We're the only community foundation that has any of those three positions in the country, but they work closely, and they went to Germany and came back with helping to bring IBC Solar's U.S. headquarters to Cleveland. They also have been helping the county and very much with a Spanish company that's very involved in looking to put turbines on the lake that came to us from Professor Garcia-Sanz and the Institute, the Great Lakes Institute. So we're helping with that. Recently, we helped to bring the European Union's Chamber of Commerce and Industry to Cleveland. Their headquarters now for the U.S., the Small and Medium-Sized Enterprise EU Trade Office is in Cleveland, inside the Greater Cleveland Partnership's offices. And they represent 300,000 small and medium-sized European companies. And so we're really hoping that there'll be some great trade there. And we help to set up and have been giving grants to fund the whole wind turbine supply chain work that's being done here. Just this morning, I was with Norman Dianne, Dean of Engineering at CASE, for breakfast with a few others, talking about a European car company with a new type of technology that we're trying to attract to the area and how we would do that. In terms of our work with CASE, we're working with CASE, which is just a fabulous partner for us across the board. They've been a partner with us in workforce development. We're putting together a solar collaborative where all the anchor institutions in town will help us train prisoner reentry and other high school dropout workforce to install solar on our anchor institutions and have a fund to do that. So CASE is working with us very closely on workforce development. They were extremely great partners with us, or we with them, on the public policy aspects of getting the bill passed that we needed. We're really proud and honored that we gave the initial grant to start the Great Lakes Energy Institute at CASE, $3.6 million, I think it was. And of course, in all of these economic development solutions, as I mentioned, we're frequently on the phone with all the members of this team. I just want to say that we view our relationship with CASE in general, but the Institute in particular, as a major long-term strategic alliance. It is not a, we gave them a grant and now we can forget them, or, we gave them a grant and we think they'll do fine. We think they will do fine, probably with or without our help, but we're committed to being a long-term, really strategic partner. We feel very fortunate to have a major national research university in our community and feel that in all areas, not just energy, if CASE is not wildly successful in the years to come, Cleveland will not be successful either. And so innovation is what will save Cleveland. CASE has to be the major fountain of innovation for this area. There are others. Obviously, we have great industrial companies. We have other great universities doing great things. But we really feel that CASE and this institute is critical. So with that, I'll end, but just say that it's been a real pleasure to work with all of these other institutions up here represented on the panel. Thanks.
Thank you. I'm going to put them to work here in a moment with questions and answers from the group, but if I could just take 4 points that came out, I think, almost threads of everything that was said. And Mario, I liked your little story, so I'm going to just put it in a continuum of years. A lot of folks talked about 100 years ago in this community, the oil industry started, and today we still have the same manufacturing base, the same intelligence, the same talent, the same port system. We didn't talk about Port of Cleveland, but we have a lot of what was here 100 years ago to build the community still existing today. I think in the presentation from Bob about 50 years ago, electrochemistry became really a platform for CASE, which today drives our opportunity in storage and in fuel cells, but it also gives confidence that the ability to build a wind industry or something else that will sustain in 50 years is sitting in front of us. So I think that was an interesting story, one I had not heard before, that actually weaves through many of these pieces. I think for the current time period, I would say that we are fortunate with whom spoke, but I also noticed while I sat here the others that are in the audience, which equally could be up here today. We have an enormous amount of talent sitting inside of the room that I think matches what Ron mentioned, which is to be successful. It's the talent in this room to take us forward. And then to pick up on a comment Peter made about 30 years from now for his daughter. Or you and Alexander and I were at Colorado School of Mines 3 weeks ago, and the sustainability professor there said that someone raised their hand and asked him recently, what will the island of Manhattan, when it comes to energy, look like in 150 years? And I think anything we're doing right now is setting us up for that. So if we could ask anybody that wants to ask questions of any of the panelists, we welcome them. We have 15 to 20 minutes here that we welcome taking them.
Question. It's a highly theoretical question. How does the symmetry of charge in the electromagnetic force, how closely related is it to the symmetry of energy in the electromagnetic force?
Bill Mason would like to know if he should handle that. Do you know if the prosecutor can take on wind, why can't he take on that question? I think I'm looking to Bob Savinell to begin.
Well, I'm looking at a physicist right now that maybe he'll answer that question. You want to go for it, Bill?
Symmetries are very important things in nature, and I'm sure that there are symmetries underlying many of the technologies that we're looking at that have yet to be discovered, but will be very important when we do get to them, and that's going to be the goal of all of us.
I have a very quick question. Do we have a sense yet what the federal commitments to alternative energy will translate into in terms of research dollars coming into this region? And also, for that matter, non-research dollars?
Well, maybe, why don't I take this in a couple of pieces, and one would be just to give a general view that of what we're seeing in terms of dollars available, because that's always the first thing, is to understand what's available. And then in particular, maybe ask for a view of what we are going after to Bob Savinell. And then I would like to finish with Bill Mason, who talked about some dollars that are already beginning to flow in other areas outside of energy, and that could give a spectrum. We just met yesterday, actually, with our federal agency, our lobbyist agency, to take a look at the dollar buckets that are available in energy that we want to ensure we go after. And, you know, the good news in this is there are large buckets of dollars. They are $3 billion in some cases through the Department of Energy. There is an EERE, the renewable area, that has $2.5 billion available. There are Department of Labor and Department of Defense grants that have availability through energy, which are quite significant, over $1 billion. There are National Science Fund, NSF grants that are available, and I'm sure I've forgotten some, but as well, there are State of Ohio grants that have come through the stimulus package that we will have availability through energy. So when we look at those, and when we look at which ones will be energy and will be available to us, I would say we had a good conversation that there's money out there. And now the important piece is being able to make sure that we, as it's a bit of a dam right now, as we called it yesterday. There's lots of people working on it, and it's sitting behind a very large concrete structure. And in energy, when that structure gets a bit of a leak here soon, it's all going to come flowing quite quickly. We think that is within the next month or so. So with that, I might just turn it over to Bob to talk about just a couple thoughts of how we actually go after that, and then pass to Bill.
A couple answers to that question is, in one area is the Energy Frontiers grant program that was started by the Department of Energy this past year. It was sort of unfunded when they announced it last summer, and universities like CASE responded with several proposals, and now it appears through stimulus funding that these Energy Frontier centers will actually be funded. And I believe there's anywhere from $100 to $200 million set aside for these programs. CASE has actually put in two proposals into that activity. One I already talked a little bit about in the area of electrochemical energy storage, new very high power type battery systems for energy storage. And the second was in the area of carbon dioxide sequestration. In regards to the DOE, other agencies that have funding initiatives coming out, They haven't released a lot of information on these things, but the EERE is coming out with an announcement soon, I understand. There's an initiative for this ARPA-E, the Advanced Research Projects Agency, modeled after DARPA, but focused on energy. That has been sort of announced, but there's a lot of activity going on in the federal government right now of how to staff it and how to organize that organization. We're trying to stay ahead of that and keep our ears to the ground on how that's working out, to see if we have a role, or we definitely want a role in that organization in pursuing those type of advanced research projects type funding. And then finally, I'll just mention the area of infrastructure. DOE and National Science Foundation has a couple, it has a number of dollars set aside from stimulus funding for research infrastructure. The announcements haven't been laid out yet exactly when the proposals are going to be due and what the formats are going to be due, but our intelligence tells us that it's coming out probably at the end of this month. And there'll be a relatively short time frame to respond to these things. And the Energy Institute here has been formulating plans and ideas on what we need in terms of supporting research and the initiative here on campus. And the School of Engineering is also looking at its needs in terms of really improving the research infrastructure in the School of Engineering and also across the campus. So that's about all I can really say.
I think that's good. Two themes I would put into that we've heard almost across the board. We've heard the themes that the dollars will be larger, so the size of the grants will potentially be larger, which behooves us to enter into partnerships, and we're doing just that with other institutes as well as with NASA Glenn because of the opportunity we have. And secondly is most ends with job creation. And what that means is the importance of industry collaborators, thanks to Parker Hannafin, which is one with us on the right project in Columbus right now, will be crucial inside of this piece. And then, Bill, you had mentioned before we started something going.
Yeah, I mean, the numbers that I'm going to talk about are much smaller than the ones you want to hear about, but it's to give you perspective on how quick the money's moving through. I head up an Internet Crimes Against Children task force for the state of Ohio, and they announced funding, this new funding to create some new jobs. What the whole intention was of $1 million for the task force. My proposal had to be in within 2 weeks, which was last week. They're going to accept it within the first week of May, and the money's going to be to me by June, so I'm ready to spend it at the beginning of June. The city and the county also had some weatherization money on the same track for about $1.5 million that they pushed through on the same time frame. And lastly, there was a law enforcement grant for about $2.7 million just for our county that came on that same path. We had to give them last week again how we were going to spend it, what we're going to do it for, which we did. In the beginning of May, they're going to tell us it's okay, and we will be able to put that money to work the 1st of June. So it's moving really quick when they pushed it out.
Thank you.
Hi, Bob, thank you for saying kind words about Megajoule and the Global Energy Storage Innovation Center. Dianne, maybe you could say a little bit more about how collaboration plays into the opportunity to expand research here in Ohio related to energy.
Yeah, so, and if this doesn't hit the question, please shout back. But I think, you know, one of the things we've taken a look at CASE is where are we very strong? And utilizing those areas to think about our next areas into research, but as well utilizing that information to think about where aren't we strong and we need support. And Ohio is a region that is rich with lots of support. One example I spoke earlier about NASA Glenn is the strength of NASA Glenn and some of the research as well as testing facilities that are there. We've been lucky. NASA offered, and of course we accepted, to have an executive in residence for the last 4 months in the Institute. And it really is twofold. One, it provides us the opportunity to be able to share and compare what's going on in both facilities. But secondly, we would hope and expect that it allows us long-term the opportunity to work together and to think about the type of collaboration that takes place. So strengths are critical to understand, but I think we're also recognizing that equally critical are the areas where we can go out and use others to fill in our gaps for us. Two of the things, looking at the medical field and how well this region has done in taking research into actual commercialization and applying that to energy, we've learned a couple of things. One that has come from some of the largest investors in the world in renewable energy, KOSLA and Virgin Green Ventures, which is a London-based venture company. KOSLA's put $400 or $500 million recently into renewables, is that the energy system requires very large dollars to get in. And KOSLA is founded by the person who founded Sun Microsystems, who speaks powerfully that to get into the software IT area, you could get in for lower dollars. And here, it takes a lot of money to get into energy. And the second is a bit different than even in the medical field, is that anything you develop works in a huge system, and you have to understand all of the components. So as well, I think, Herb, the need to have collaborations is quite critical for some of the development and research in energy that we're going through.
One thing, sorry.
Perhaps maybe just another question?
Yeah, I'm sorry. We have a question from Second Life. We have an avatar who has a question. We've been simulcasting this at
Okay.
Second Life. The avatar asks, what kind of challenges are there, if any, adapting the power grid for wind power? How costly and how have existing wind farms dealt with that?
That is an excellent question, and I'm hoping I know who's thinking of answering it. Mario.
Well, there are many things in this area that we can talk about, but just one example. Right now in the countries in Europe with more amount of wind energy, like Germany, Denmark, and Spain, the problem, there are many new problems, but one of them is, for example, voltage dips. That it means that if the voltage is going down for just half a second and then is going up, that is very normal in any grid. Then the normal or the classical technology are stopping the machines, the windmills. So that means that if you have 20% from wind energy and suddenly you have nothing, from wind energy, other power station has to put this energy into the grid. So there are new regulations in this area, for example, to that you will not be able to connect new wind farms unless you solve this problem. That means that just after the event, you have to be connected, not to disconnect the windmill, because if you are disconnecting the windmill, you need 4 more minutes to restart up the system. This can be a huge problem in terms of the frequency, the stability of the grid in terms of frequency, controlling the frequency and the voltage and things like that. So there is a lot of research right now in this area. There are new systems. So this is just one example of what kind of problems we can have with wind energy. But anyway, with the new systems, we are right now able, to solve this problem with very advanced designs. And also we can, from a wind farm, to help the grid to control frequency and voltage in any way. That is a very good news, because with that we can just for the grid operator, to give the grid operator the possibility to do many things with the grid. And then I think this is one of the main problems in terms of grid integration. So wind energy is not just a system that is introducing energy and then producing some kind of problems. It also has to be also a system to control the grid itself, the frequency, the voltage, and things like that. And there are many new projects in this area, and also a lot of research to do.
Thank you. Thank you.
One thing I haven't heard addressed is there is a lot of waste energy that we don't recover. For instance, back in the 30s and 40s, we recovered a lot more energy from our coal power plants than we do today, because we recovered the thermal energy. Today, there's no real attempt to try to recover that thermal energy from coal power plants, from the nuclear plants even. That's a lot of waste energy. There's a small company in Tremont that has some interesting technology that could be adapted to recover waste energy from roads. For instance, every car passes a bridge or anywhere it creates vibrational energy. These kinds of waste energy, we could reduce carbon output just by recovering all the energy that we waste every day from what we already have in place.
And you're right. I know one of the thrust areas is efficiency. I don't know if you want to talk at all about that, Bob.
That's a very good point. You know, a lot of the short-term gains we'll get over the next decade or so will be enhancing efficiency and recovering energy. I've been involved with a project, for example, that's primarily out of the Savannah River plant process. They do nuclear fuel processing down there, but they're looking at an electrochemical process that's based on a sulfuric acid cycle to recover waste heat from nuclear power plants, which can be applied to all sorts of different applications. So I think that's an important area that that we have activities at CASE addressing, but not as coherent or as visible as perhaps some of the other areas we have.
If I could respond. So this topic area, at Parker we call this energy harvesting, actually not at Parker, at many other places. Energy harvesting is a separate market from primary power generation. The order of magnitude of the power you can generate with that is much smaller than what's needed for primary power generation, but we see as important technology for us. Many of the things that we're doing at Parker require some kind of battery or power source to power a sensor or a control. So that often becomes a limiting factor in deploying that technology to use. So we're looking at energy harvesting applications in a variety of technologies, not just Aaron's, but many other types of technology like piezo technologies or electroactive polymers as well. I think that the important thing to remember, though, and I've seen several schemes now that extract energy from roads, the important thing to remember is that it's waste because the energy is being used in the first place to cause emotion, okay? Rather than looking at extracting energy from that process, because if you extract the energy, you have to generate the energy to be extracted. Try to find some way to increase the efficiency of the system so you don't have the waste in the first place, okay? And that's probably the prime mover in terms of trying to increase efficiency in my mind. But energy harvesting is extremely important. If you go on the web and look at a company called Enocean, E-N-O-C-E-A-N, you'll see a company that was spun off of Siemens that is actually making a commercial splash with various energy harvesting devices for power and light control, okay? It is a very growing topic area, and I think Aaron's got an important future in that.
Another thing that goes along with energy conservation is distributed energy versus the grid, because the grid is so inefficient and it makes us as a country very vulnerable to terrorism.
Mm-hmm. Thank you. Bill, Mario, Pete, Leo, Lori, Bob, and Ron, thank you very much. Much appreciated. Thank you, everybody, for joining.